Looking at our first derivative rule, we have the derivative of a constant. So looking at this example here, we have ln of 2 pi, e squared, 6. These are all constants. You could type it into your calculator to see what unified number it would be. And no matter what, the derivative of every single constant is 0. If it doesn't have an x on it, it has a derivative of 0. If we make things more interesting and start having x's to a power, our first original power rule would be if we have y is x to the n. The derivative of y equals x to the n, our derivative would be called y prime. We would bring down the power n and subtract 1 for the new power. So n to the x times x to the n minus 1. If we use this on this first example here, we have h of x is x to the 17th. The derivative of that would be bring down the power, 17, we multiplied out front, and raise x to the 17 minus 1 is 16. I put these three rules in boxes right next to each other because they're essentially the same thing. So if we move over to the next rule, that says what if we have a constant multiple out front? K times x to the n is our original function. Instead of just being x to the 17th, it could be 5x to the 17th. Well, this rule says that the derivative y prime would be keep the constant multiple k, and then we'd still just bring down the power and subtract 1 for the new power. So if you have a constant multiple, you keep it, but it doesn't impact how you take the derivative. If we try that with this first example here, we have h of x. We would do the same thing we just did before. We brought down the 17 and raised x to the 16. Now we have some different numbers, but I'm going to call the derivative h prime of x still. And I'm going to keep that constant multiple 2 and bring down the 7. So 2 times 7 is 14. And then we have x to the 7 minus 1 is to the 6. The next rule over, I have it all next to each other because it's all essentially the same rule, is what if we have two terms added or subtracted together? So what if we have a first term plus a second term? What if we, instead of just having x to the 17th, had x to the 17th plus x squared? Well, this derivative, y prime, would be found by just taking that derivative of the first factor normally, and then adding the derivative of the second factor. And this would be plus or minus. Even if they were subtracted, you'd just take their derivatives normally. So if we look at this third function here, this h of x, we would still call the derivative h prime of x. And having something added or subtracted doesn't change how we take the derivative. We would still bring down the power, so 7 times 3 would give us 21. X to the 3 minus 1 is 2, so we have 21x squared. And then if we try to bring down this first power here, since it's just x, it's really x to the first, we'd have negative 2 times 1, which would just say negative 2. And then you'd have x to 0, which is also just 1. Anything to the 0 power stays 1. So the derivative of negative 2x is negative 2. Derivative of 35x is 35. Derivative of 14.6x is just 14.6. When it's x to the first power, it ends up having a derivative of whatever the number in front of x was. So now we have a few more examples of all these rules, which is really just going to be that we're going to continue to bring down the power and subtract 1 for the new power. So going back to this one here where it doesn't have a coefficient, the hard part about this next row is we have some algebra to rewrite. If a power is in the denominator, it is really a negative power though. So we really have 1x to the negative 8 because we want to pull it out of the denominator. Once it's out of the denominator, we are able to take the derivative normally. We're going to bring down the power, negative 8, and raise negative x to the negative 8 minus 1 is negative 9. We could do that same thing again. Next door, we have 3 over x to the 6. We want to be able to bring down the power and subtract 1 from the new power. So we're going to rewrite it as 3x to the negative 6, negative because it was in the denominator. And now we can take the derivative. We're going to call it y prime. And we're going to bring down that power. 3 times negative 6 is negative 18. X to the negative 6 minus 1 is negative 7. And next door we have the same exact thing. We're going to keep bringing down the power, subtracting one for the new power, but again, this has some algebra first. That's the only difference between the second row compared to the first row, is we have a negative exponent. It is 5x to the negative 4 plus 3x. Rewrite the whole original function. We have to rewrite it because the x was in the denominator. Now that it's rewritten, we can take the derivative though, which means bring down the power. So 5 times negative 4 is negative 20. X to the negative 4 minus 1 is negative 5. And the derivative of 3x is 3. Because it's x to the first power, we just take the number out front. 3 times the power of 1 would just stay 3. So it's all the same rules over and over again. That whole row is a little bit harder because we had to rewrite some negative exponents. And this last row, we're going to keep doing the same exact thing. We're not going to panic, but there is going to be more algebra in the next one. Looking at this first one here, we have the square root of x to the 5th. So we want to remember from algebra that if it's under a root, it'll rewrite to be a fraction power. And it's always the power over the root. So this one is x to the 5th power, so the 5 is going to go on top. And the square root really means the second root. So we really have x to the 5 halves. So we reviewed 2 algebra rules here. We said if it's in the denominator, it's a negative exponent. And if it's a root, it'll rewrite to be a fraction. Now that we have this fraction, we're going to do the same thing that we did with x to the 17th, right up top there. It's the same exact rule, but now we have a fraction to bring down. Doesn't change anything. We're going to have 5 halves. X to the 5 halves minus 1. You could use a calculator, or you might be able to do this in your head. 5 halves minus 1. You just subtract the numerator. It's going to be to the 3 halves. Same concept with the next one. We have 4 over x, the 8th root of x, which is really as hard as it could get with having to rewrite with algebra. We have a couple things going on. We want to pull x out of the denominator first of all, so we're going to have to make it a negative exponent. And then we also have it under a root. It's under the 8th root, which means it's going to rewrite to be a fraction. So this one's a negative fraction, negative because it was in the denominator, and a fraction because it was a root. So to rewrite these roots, it's always the power over the root. So if it's just a regular x in here, that's x to the 1st power, and it's under the 8th root. So power over root ends up being 1 over 8, and it's a negative 1 over 8 because we pulled it out of the denominator. Now we are all set to take the derivative. We are just going to keep bringing down the power and subtracting 1 for the new power. So I'm going to bring down the negative 1/8. I have 4 times negative 1/8. You could multiply this out if it's easy enough for you to do, like we did above. We said 3x to the negative 6. We multiplied that right out to be negative 18. This one you might not be able to multiply in your head, but you could use a calculator if you want to. And then you have x to the negative 1/8 minus 1. So negative 1/8 minus 8/8 is going to give us negative 9/8. And then we could certainly multiply these out. 4 times negative 1 is going to give us negative 4/8, which is the same thing as negative 1/2. X to the negative 9/8. Last one over here, we have another function that needs to be rewritten. I know that because there's a root. This one is a square root, so it is x to the 1st power over second root when it's just a regular square root. Plus x squared plus x, that didn't really need to be rewritten, but we'll rewrite the whole thing, and then we'll take the derivative of the entire thing, which means bringing down the power and subtracting 1 for the new power. So we're going to bring down the 1/2 x to the 1/2 minus 1. 1/2 minus 2/2 will give us a negative 1/2. Derivative of x squared is 2x. And then the derivative of 1x, well, we saw up above the derivative of negative 2x was negative 2. The derivative of 3x was 3. So the derivative of 1x is 1. And there are 4 derivative rules. And once you know the power rule, You can apply that whether there's a constant multiple or a sum or difference. What makes it more difficult is adding in the algebra. If it's from the denominator, it's a negative exponent. If it's under a root, you're going to rewrite it to be a fraction, power over root.